Potential difference. What is the potential difference? Okay, you can see here this circuit in front of you. So what can we say the potential difference between 2 points, like this point, point A, and this point, point B? It is the energy transferred per unit charge. So the energy transferred from A to B per unit charge. So unit charge is 1 coulomb. So if 1 coulomb moves from A to B, or when we move 1 coulomb from A to B, work is done. The work done is called potential difference. So the potential difference is the energy, the potential difference between 2 points, A and B, is the energy transferred per unit charge as the charge moves from point A to point B. So this is called the potential difference. It is the energy transfer or rate of transfer of energy. Then the potential difference denoted by delta V. Delta V, it is the potential difference between point A and B. So delta V, it's VB minus VA. It is the energy transferred per unit charge. Then we have another formula for potential difference. So the potential difference is the energy divided by a charge. So this is called the potential difference, measured in volt. Then the energy transferred, denoted by W, divided by Q, is the potential difference denoted by V. So V equals work done over charge. Work done measured in joule, charge measured in coulomb. Then the unit of potential difference is 1 volt. Then we can say 1 volt equals 1 joule per coulomb. We can draw this triangle. So the voltage equals the energy over a charge. The energy or the work done equals V times Q. So this is also important formula. W equals Q times V. But we studied before Q equals I times T. Then the energy equals I times T times V. Then we have many formulae. We can remember that formula. The first formula is that Q equals I multiply T. This is the first formula. The second formula is that the energy equals Q times V. The third formula or the third triangle is that the energy equals I times T times V. Then we have 3 formulae. I said Q, the first triangle, Q equals I times T. So this is the first rule. The second, the energy W equals Q times V. The third, the energy equals I times T times V. I is the current in ampere, T is the time in second, V is the potential difference in volt. Okay, now 1 volt, this definition is important. 1 volt is 1 joule of work to be done to move 1 coulomb charge between 2 points. So 1 volt is the work done of 1 joule to move 1 coulomb between 2 points. Now, let us see this example. We read the example and then let us discuss it. In the circuit shown, the potential difference across the lamp is 6 volt. Then we have given V equals 6 volt. If 15 coulomb of a charge passes through, okay, so this is passes through, So here we have given also Q. Q equals 50 coulomb. Pass through the lamp, how much electrical energy transferred to heat and light? So we need W. Which formula we use it? W equals Q multiply V. Now we can solve this. So energy, W equals Q. Q here is 50. Multiply 6. 6 times 5 equals 30, so 300. And the unit of energy is joule. Now, let us we see the next question. Okay, there is no circuit here, so we can, don't worry for this. Okay, in the circuit, the voltmeter reads 10 volt. There is no circuit in front. Yeah, so no circuit. Then just we write the given. 10 volt, so this is the given, it's voltage. So the voltage equals 10 volt. And the ammeter records current of 0.2 ampere. So this is the current. I equals 0.2 ampere. How much energy is transferred to heat and light in the lamp in 5 minutes? Then we have the time. The time equals 5 minutes. Now, we have to convert minute to second. Then we multiply it by 60 to correct from minute to second. 5 times 6 equals 30. So 300 seconds, this is the time. Okay, in the circuit, and okay, how much energy? Then the required is W. Which formula we use it? W equals I multiply T multiply V. This is the formula that we can use. The current is 0.2. The time is 300. And the voltage is 10. Then we use the calculator to get the answer. 0.2 multiply 300 multiply by 10. So the answer is 6 multiply 10 power 2. In norm, it is 600. 600 watt, 600 joules. Write that 3 rules in front of you. Okay, to be easier for you. The first rule, this is the first rule. Okay, Q equals I multiply T. The second is that energy equals Q times V. The third is that energy equals I times T times V. Write that 3 rules in front of you. This is rule number 1, rule number 2, rule number 3. So it will be easy to solve any question. Okay, check your answer. Now we read the question together. Okay. Lamp has potential difference 12 volt. Then we have V. The voltage is 12. Calculate how much electrical energy. Then the required is the energy W. Transfer it when a charge of 400 coulomb. So this is the first part. Q equals 400 coulomb. We have the voltage and we have the charge, so we can get the energy. So for part A, we use the formula, the energy equals Q multiply by V. Q is the charge in coulomb, 400. V is the potential difference in volt, 12. We multiply 4 multiplied by 12, it's 48. So it's 4800 joule. So this is part A. Now, part B said a current of Now, part B, we have the current. I equals 2.5 ampere. Pass through it for 30 seconds. The time is 30 seconds. Already, we have at the beginning, the voltage is 12. Then we have V, and we have the current, and also we have the time. Then we use the formula, the energy equals I times T times V. We do substitution. I equals 2.5. The time is 30, and the potential difference is 12. 2.5 multiplied by 30 multiplied by 12. So the answer is 900. 900 what? 900 joules. So the answer is 900 joules. Okay?
Okay, Mr.
Next. Now we talk about electromotive force. Electromotive force, it is the voltage of the power supply, the maximum voltage in the circuit. A power supply or battery transfers energy to electrical charges in the circuit. So the EMF denoted by E, epsilon, of supply is also defined as the energy transferred per unit charge. But this is the energy for the whole circuit. So EMF is the total work done per unit charge if 1 coulomb. When the charge flows around a complete circuit, then when we move 1 coulomb in the complete circuit, the work done to move 1 coulomb, okay, around the complete circuit is called EMF, denoted by E. It is the same. It is energy transferred per unit charge, but around the complete circuit. So the energy transferred W equals Q times EMF. Again, the EMF equals the energy transferred per unit charge. But this energy transferred for the whole circuit, the work done to move 1 coulomb of the whole circuit. So remember the difference between potential difference, denoted by V, and EMF, denoted by E. What is the difference between both? V, or potential difference, is the energy transferred per unit charge between 2 points in the circuit, between A and B. So the work done to move 1 coulomb between A and B is the potential difference. But the energy transferred to move 1 coulomb around the whole circuit, not between 2 points, between the whole circuit, this is called EMF. So this is the potential difference, and this is the EMF. EMF is the energy transferred per unit charge, and the potential difference, energy transferred per unit charge. But the first one between 2 points, the second one EMF between the whole circuit. Okay? Now, we have another definition of EMF and potential difference. But okay, let us remember this note. EMF stands for electromotive force. Electromotive force, not stand for the force. This is not a force. It is just the voltage. Now, the difference between both again, yeah. So this is the energy converted from electrical to any other forms per coulomb. This is the potential difference from electrical to any other form. But EMF, the energy converted from any other forms to electrical. This is inside the cell or battery per unit charge. So the potential difference, energy converted from electrical to any other forms per coulomb, but EMF is the energy transferred from any other forms to electrical per unit charge or per coulomb. Okay? Do you understand the difference now between potential difference and EMF? Again,
Yes, Mr.
This is a circuit contains, for example, bulb, contains resistance, okay, contains motor, And finally, it has a battery or cell. Potential difference is the energy transferred from electrical to light per coulomb, or energy transferred from electrical to heat per coulomb, or energy transferred from electrical to kinetic energy in the motor per coulomb. So this is called the potential difference. But EMF, it is inside the cell. It is the energy transferred from any other forms to electrical, from chemical to electrical, from solar to electrical. Okay? So this is the difference between potential difference and EMF according to energy conversion. Again, the potential difference, energy converted from electrical to heat, to light, to kinetic energy per coulomb. This is potential difference. But EMF is the energy transferred from any other forms to electrical. For example, inside the cell, from electrical, from chemical to electrical per coulomb. Now, both of them energy. So the potential difference V is the energy, okay? The energy per unit charge. And EMF also the energy per unit charge, both of them. Now, let us we see this example. How much energy is transferred to 1 coulomb of a charge? So Q equals 1 coulomb. A battery with EMF 2 volt. Now we need what? We need the energy. The energy equals the Q times the V or EMF. Q equals 1, EMF it's 2, then the answer is 2 joule of energy. Now, 5 kilovolt, then the voltage is 5,000 volt, 5 kilovolt. And here, the charge is 1 coulomb. So what is the energy transferred? Energy equals Q multiplied by V. So Q equals 1 multiply 5,000 equals 5,000 joule. Okay? Now, let us we see the next part. Now try to solve here this example. Try to solve it. Yes. Now, I said we have two formulae. V equals W over what? Over Q. Then from this, the energy equals Q times V. EMF equals the energy transferred per coulomb. So the energy equals Q times EMF. It is the same formula. Okay? Now, in the first part, to reduce the time, how much joules of energy? So we need W. There's a battery of EMF. So this is EMF 3 volt supply when a charge of 55 coulomb. So Q equals 5 coulomb and EMF equals 3 volt. We need the energy transferred. Then in part I, the energy equals Q times EMF. Q is 5 and EMF is 3. 5 times 3, 15 joules. Part 2, there is a current of 2 ampere, 0.2 ampere for this. Now, EMF equals what? Equals, the energy transferred, yeah, the energy transferred, W equals I times T times V. V or EMF, here we can say EMF or V. It is the same like I times T times V. Then the energy equals, the current is 0.2, the time is 30, and EMF is 3 multiplied by 3. Then we can get the answer. So 0.2 multiplied by 3 multiplied by 30. So the answer is 18. So the answer is 18 joule. Okay? Now, I said the lamp two lamps are connected in series to a battery. State the energy transformation that occurs in the battery. So the energy converted from chemical to electrical. In the battery, the energy converted from chemical to electrical. In the lamp, from electrical to heat and light. Okay, so this is the energy converted in the battery. Okay, in the battery, the energy converted from chemical to electrical, but in the lamp, from electrical to heat heat and light. Next part. Now we talk about the resistance here. Resistance of conductor is the ratio of potential difference across it to the current passing through it. The resistance denoted by R is the ratio of the potential difference denoted by V to the current I. Sometimes we say this is sambusa. No, it's like sambusa. So this is V, and here I, and this is R. So R equals V over I V over R, V equals I times R. Electrons move more easily through some conductor than the other. So the good conductor has less resistance. The bad conductor has more resistance. Now, this is the formula for resistance denoted by R, measured in ohm. So the unit of resistance is ohm, equals V, the voltage over the current I. So remember this sambusa law. Now, the unit of resistance is 1 ohm. So 1 ohm is the resistance of conductor, which the current is 1 ampere when the voltage is 1 volt. So 1 ohm equals 1 volt per ampere. 1 volt per ampere. Okay? So this is the definition of ohm. Now, next part, let us resolve this question. All electric devices are required to have identified plates that specify their electrical characteristics. The plate on a certain steam iron states that the iron carries a current of 6.4 ampere. So the given here is I equals 6.4 ampere. When connected to 120 volt, so this is V, 120 volt. What is the resistance? We need R. Remember to draw this triangle. It is sambusa law. V equals I times R. We need R. So R equals V over I. V is the potential difference in volt, 120, over I, 6.4. Now we do this. 120 divided by 6.4. The answer is 18.75, and the unit of resistance is Ohm. Next part, or next question. Now try to solve this question. Okay. Now, resistance, so we have R. R equals 48 ohms. How much current? So we need I. Does the plate carry when connected to 120 volts? This is V, 120 volt. Now the formula is that sambusa law, V I times R. We need I, then I equals V over R. V is 120 over R, 48. Now 120 divided by 48, so the answer is 2.5. 2.5 watt ampere. The unit of current is ampere. Next part. Ohm's law. Ohm's law is very important. He said, for a conductor at a constant temperature, so the conductor must be at a constant temperature, so this is very important. You have to mention this. The current is proportional to the potential difference. So the current is proportional directly to the potential difference. So the relation between the current and voltage is a straight line passed through the origin. In case of what? If the temperature is constant. This is called ohmic material. Ohmic material that obey Ohm's law. It means the relation between V and I is direct. So remember, V proportional directly to I in case of what? In ohmic conductors. Most of metals are ohmic conductors. So we have ohmic conductors and also we have non-ohmic conductors. The difference between both is that ohmic conductors, the relation between V and I is direct, straight line, but non-ohmic material or non-ohmic conductors, the relation is not a straight line, it is a curve. We have two types of non-ohmic materials. We have diode and we have the bulb or lamp. We will study both now. So in case of resistance here, the slope is constant. The relation is a straight line between I and V. Okay. So this is ohmic material. It is a straight line. So the resistance here, because R equals V over I, but this is IV graph. So the resistance equals 1 over the slope. Because the slope is a straight line, it is constant, then the resistance is constant. So for the resistors, it has constant resistance. طبعا under condition the temperature is constant. Filament lamp, this is IV, V, remember this is I and this is V. It is a curve like this. So filament lamp, it is non-ohmic material. The relation is a curve. Okay, this is for the filament. Now, diode allow the current path in one direction. The relation between the current and voltage is not a straight line, it is a curve like this. So remember, we have three relations: a straight line for ohmic material, and then for bulb or lamp, it is a curve like this, and then for diode, the relation like this. So we have three types of materials, or two types of materials actually. Materials that obey Ohm's law, the relation is a straight line. Materials do not obey Ohm's law, the relation is a curve. We have two types of materials do not obey Ohm's law: semiconductor diode and bulb. Now for diode allow the current path in one direction. So this is a positive, this is the current. So you can see if the arrow, it is the same direction, it is the same as the triangle of diode, then the bulb will be working. This is forward, but this is the current here. So this will be stopped to move the current. Then this is reverse diode. So this is forward diode and this reverse. The first one is forward and the second one is reverse diode. Diode is semiconductor, allow the current path in one direction. Now, look at this. This is conclusion. So this is for what? For ohmic material. The relation is a straight line. This is for non-ohmic material. We have two non-ohmic materials, filament lamp and diode. But take care for the difference between the two curves. All of them IV graphs. So remember, this is IV and this is IV. Also, this is IV graph. Okay. Now, next part. He said the diagram. Now try to think of this question and then try to solve it alone. He said, which two graphs, just we choose two graphs of that four graphs. Two graphs shows characteristics of ohmic resistor. Ohmic resistor, the relation is a straight line. So ohmic resistor is X. And filament lamp. Lamp is white. What about that? It is diode. It's okay. Then this is here ohmic. This is ohmic resistor, and this is filament lamp. But the last one is the diode. Okay, so this is the difference between. Next.
Yes, Mr.
Yeah, good. Now, the effect of temperature on resistance. You have to remember this. The resistance of metal increases as temperature rises. So when the temperature increases, the resistance increases in case of metal. Why? Because the atoms vibrate more, and then the electrons cannot move easily inside the metal. So the resistance of the metal increases when the temperature increases, but it is not direct relation. It is not, because it is not a straight line path through the origin. In case of semiconductor, no. Decreases, the resistance decreases when what? The temperature increases. This is in case of semiconductor diode. It is opposite to the metal. Semiconductor diode, we have thermistor or diode. So when the temperature increases, the resistance decreases. So remember that, please. Okay. So this is the difference. Now I can leave this example as a homework for you, just to think of it, because the time. Let us see the
Inshallah.
next part. Inshallah. Now we talk about the resistivity. Resistivity denoted by rho. Actually, the resistance proportional directly to the length of the wire. When the length of the wire increases, the resistance increases. But it is proportional inversely to the cross-section area. When the area increases, the resistance decreases. Then we can say the resistance proportional directly to the length and inversely to the area. Then we can say the resistance equal constant multiply L over A. This constant depends on the material called resistivity, denoted by rho. Then this is the formula, R equals rho L over A. Rho is constant, it depends on the material, called resistivity. Its unit is ohm meter. So we have two symbols, resistance denoted by R and resistivity denoted by rho. What is the difference? Resistance depends on the shape of the wire, the length or area, but resistivity depends on the material. Then, what about the resistivity and the temperature? The same as the resistance and temperature. So remember, the resistivity and the temperature and resistance and temperature of conductor or metal. Now, this is the resistance and this is the temperature in Celsius, and this is the resistivity and this is the temperature. Both of them, it is a straight line but does not pass through the origin. So this is the relation between resistance and temperature, and also resistivity and temperature. Now, for a metal in the shape of wire, R depends on four factors: the length of the wire, the cross-section area, the material, denoted by rho, and the temperature, denoted by T. Then the resistance of the wire depends on the length, direct, depends on the cross-section area, inverse, depends on the material, the type of material, also depends on the temperature. When the temperature increases, the resistance of the wire also increases. Now, try to solve this example. Try to solve it. Read the question, be careful, write the given, and try to solve. By the way, most of conductors are circles or cylinder. So the area is area of circle by r squared. So remember, the area is by r squared. R is the radius. What is the relation between the radius and diameter? The radius equals half diameter. So remember, the radius equals half the diameter. Calculate the resistance. So the required is R of copper wire, 1.0 kilometer length. L must be in meter. So it's 1 kilometer. It means 1,000 meter. And 0.5 millimeter diameter. So the diameter equals 0.5 millimeter. We convert to 2 meter, 0.5 times the 10 power negative 3 to be in meter. And we find R. R is the radius. R is the radius. It's a half diameter. So it's a half multiply 0.5 times 10 to the power negative 3. We calculate R, the radius, not resistance. Resistance noted by R capital. So it is 0.5 times 0.5 times 10 to the power negative 3. So the answer is, okay, shift mode 7, 3. The answer is 2.5 times 10 to the power negative 4 meter. We can calculate the area. It's by R squared by open bracket 2.5 times 10 power negative 4 all squared, squaring the answer, multiply by. So the answer is, this is the area, equals 1.96 multiply 10 power negative 7 meter squared. Resistivity, this is rho. We need to get R. R equals what? Rho L over A. Rho is the resistivity. So the resistivity, it's given 1.7 multiply 10 power negative 8 ohm meter. L is the length in meter, which is 1,000 because it's 1 kilometer, over the cross-section area, 1.96 multiply 10 power negative 7. Now we write 1.7 multiply 10 to the power negative 8 multiply by 1,000 divided by the answer. So it is 86.6. So the answer is 86.6. The unit of resistance is ohm. Okay. Next part. Now try to solve this question. Okay, let us check. Nichrome wire has length. So this is L. So the given is L. L equals 0.5 meter and radius R small. R equals 0.1 millimeter. We have to convert to meter, 0.1 times the 10 power negative 3 meter. What is the cross-section area? We need the area. The area is pi R squared. Pi, open bracket, R is 0.1 multiply 10 power negative 3 all squared. We can calculate this value. Pi, shift, okay, pi, bracket, 0.1 multiply 10 to the power negative 3, close the bracket squared. The answer is 3.14 multiply 10 power negative 8 meter squared. What is its resistance? Part B. We need R. R equals what? Rho L over A. Rho is the resistivity. It's given here. It's 110 multiply 10 to the power negative 8. L is the length, 0.5 over the area, which is 3.14 multiply 10 power negative 8. Now, 110 multiply 10 to the power of negative 8 multiply 0.5 divided by the answer. So the answer is 17.5. So it is 17.5. The unit is ohm.